Hello. Okay, so today in class we talked about all those different lines. We talked about the altitudes, the medians, the angle bisectors, and the perpendicular bisectors. But we only looked at what happened when we had one line at a time. Today we're going to talk about what happens when we have three at a time and what happens when they intersect. So today we're going to talk about circumcenters, incenters, centroids, and orthocenters. And yes, those are the names of the lines, or those are the name of the points when the lines intersect. So it's called a point of concurrency. So that's when you have three or more lines that intersect. They're called concurrent lines. And where they intersect is called the point of concurrency. So for example, we've got this line here. So we've got this line that goes through here, and then we have this line that goes through here, and then we have this line that goes through here. So they all intersect at one point, and it's called the point of concurrency. Kind of like when there's a bunch of streets that intersect. So it's called the point of concurrency where they intersect. These would be considered non-concurrent lines because you only have two intersecting at a time. Okay. Okay. So here we've got our non-concurrent lines and our concurrent lines. So let's hide this. All right. So let's talk about what happens here. Okay, so remember we had our perpendicular bisectors. The word bisector tells me that I need to find the midpoint of each side. So since my triangle has three sides, then I'm going to have three midpoints. So I'm going to have a midpoint here, and I'm just kind of eyeballing them, and a midpoint here. So they may not work out to be perfect, but they'll be close. So make sure you put the marks on here. I'm going to put 2 here. I'm going to put 1 on this one and 3 on this one. Okay, so that tells me this is the midpoint because those two are congruent. This is the midpoint because those are, and this is the midpoint because those two are. Okay, so now perpendicular, it means it has to be perpendicular, so it has to make a right angle through that point. So I'm going to go to the point, and I'm going to just draw a ray straight up. And the same thing here. I'm just going to kind of eyeballing it, go into the point and straight up. So now I've got 3 perpendicular bisectors, and I know they're bisectors because I created their midpoints, and now I know they're perpendicular because I am drawing those little right angle marks. Do not forget those marks. Now there's something that's really, really cool about the perpendicular bisectors, and we'll go into this later. But if you go to their point right here where they intersect, so I'm going to put me a point where they all intersect. Okay, they all intersect right there. So that point right there where they all intersect is the point of concurrency. Okay, so now what's really cool about them is if I go to the point and I draw a line, that is just way too big. So if I go to that point where they all intersect, and if I draw a line to each corner, so we have a bunch of different lines, it's a little bit confusing. Those 3 lines that I just drew are all the same length. So there is a whole lot of stuff that is congruent here because we've got all these pieces that are congruent, and now these little lines right here are all congruent. Okay, so all those arrows are congruent. So we need to remember they are equidistant, which means same distance, from the vertices. So from here to each corner, and we will get more into that later. Okay, now we have angle bisectors. So you go to the angle. Can I not just get a straight line? So I'm going to just eyeball it. Close enough. Come here, eyeball it. Go here, eyeball it. All right, so now I have my point of concurrency. So right here, where they all intersect. Okay, my thing is definitely not functioning today. So where they all intersect, this point right here, This is called your incenter, okay? It is equidistant to the sides. So to find the distance, the segment has to be perpendicular to the side. And we'll talk about that more later. So remember I told you they all had something special? Well, that's what's special about an angle bisector. All right, the next thing we have is our medians. Okay, the medians, remember we need a midpoint first. So I'm going to find the midpoint of each piece again. So again, we're just going to kind of eyeball it. So that piece is equal to that piece because I created a midpoint. This piece is equal to this piece. And this piece is equal to this piece. And now the medians, if you'll remember from earlier, you start at your corner and you just connect to the midpoint. Go to this corner, connect to the midpoint. Go to this corner, connect to the midpoint. And guess what? Where they all intersect, that's their point of concurrency, and it's called the centroid. And what's cool about the centroid is that this top distance right here, the one that starts at the corner and goes down, is 2/3 of the whole thing. So if you thought about it, if I called this A, and I'm going to call this centroid C, I'm going to call the midpoint M, then I would say that AC is 2/3 of the whole thing, AM, which means this piece down here would be 1/3. All right, and then our next one is an altitude. This one is, I think, pretty easy because you just go to your corner and drop a line straight down. So go to the corner and straight down. Go to the corner, straight down. It doesn't have to be at the midpoint or anything. All you do is you go to the corner and straight down, and it has to be perpendicular. So you have to make sure that you put the mark that says that it's perpendicular. And the cool thing about it is it can be inside or outside, or it might even be on the right triangle. So now you have to remember which one of these points goes with which set of lines. So one way you can remember is this sentence. Peter carried an important message calling all officers. Or the way I like to do it, I like to use this one. I like to say, pretty cats are inside, mean cats are outside. Because that means perpendicular bisectors go with the circumcenter, angle bisectors go with the incenter, medians go with the centroid, altitudes go with the orthocenter. To me, this one is easier than this one. You may like this one. You may be even creative enough to come up with your own, so let me know if you do. All right, so now let's talk about this. We're going to decide, based on these markings, which lines are they? So we are starting at our corners, and we're perpendicular. So that means it has to be an altitude. And if pretty cats are inside and mean cats are outside, so I'm thinking, let's go back here. I'm going to clone this. Actually, I'm just going to copy it, and then I'm going to paste it on this side so I have it. So I'm thinking in this particular sentence, pretty cats are inside. So these are my bisectors, perpendicular bisector and angle bisectors. Mean cats are outside. So altitudes go with the one that starts with an O, which is the orthocenter. Okay. So now let's do it again over here. So we have our reminder. This time I look and I see, well, I have this piece is equal to this piece, so this has to be a midpoint, that has to be a midpoint, that has to be a midpoint. Well, I'm going to my corners, so the corner to the midpoint is a median. So median is mean, so it has to be the one that starts with a C. So I always think median, middle, center, centroid, all those things kind of mean the same thing. Okay, now this one, I just have congruent angles. Okay, that's all I have is a bunch of congruent angles. So if I have a bunch of congruent angles, then I must have an angle bisector. And since I have an angle bisector, sorry, that means pretty cat's angle bisector inside in center. And that should be in center, not in centers. And the last one, I have a bunch of congruent pieces and right angles. So that means that's a midpoint. So which line was it that made a 90-degree angle at the midpoint? Well, those were our perpendicular bisectors. So when I get a bunch of perpendicular bisectors intersecting, they intersect at this point, and that point is called, so I go over here and I remember my pretty cats are inside. So since it's the bisector, it's the PCAI one. So perpendicular bisectors, and then it's the C circumcenter. So remember, we had that special property, just to refresh one more time, that special property, if you go here, if you draw a line from there to each one of your corners, all of those lines, those dotted lines are all the same length. Okay, so remember that. All right, remember, pretty cats are inside, mean cats are outside. Perpendicular bisector circumcenter, whoops, angle bisector incenter, median centroid altitude orthocenter. So if you can remember this, try to associate it with this, and you'll have it memorized. See you next time. Bye, guys.